Hello everyone, welcome to another video on the precise definition of a limit. This is Calculus 1. I have brought this one more example on cubic functions because I'm a very strong believer in the power of repetition in the teaching and learning process. So here we go. I promised in the previous video that I would talk about the triangle inequality. I want to briefly talk about it in this video, although I'm going to use my traditional approach, but I'm also going to show you how the triangle inequality works. So here's a question here. It says, using the precise definition of a limit, prove that the limit as x approaches 2 of minus x cubed plus 3x squared is equal to 4. Naturally, if you substitute the 2 into that place there, you get minus 8. Substitute 2 there, it's going to be 4 times 3, 12. Minus 8 plus 12 is indeed 4. How do we prove this using the precise definition of a limit? Well, proof. We copy the question as the tradition goes. Limit as x approaches 2 of minus x cubed plus 3x squared is equal to 4. So let us state the precise definition of a limit. Then it says, if the limit as x approaches a of f of x is equal to L, it means for all or every epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value of x minus a is less than delta but greater than 0, then the absolute value of the function, which is f of x minus the limit, must be less than epsilon. Now let us incorporate this into the precise definition of a limit as follows. Therefore, the limit as x approaches 2 of minus x cubed plus 3x squared is equal to 4 means for all or every epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value of x minus 2 is less than delta but greater than 0, then the absolute value of the function, which is minus x cubed plus 3x squared minus the limit, which is 4, absolute value of that must be less than epsilon. Now, so what do we do next? We go into our 4 steps. Step number 1, we state what we're given. What are we given? That epsilon is greater than 0 over here. Step number 2 is the choice of delta. I told you last time that as long as this function here is not a linear function, delta is always going to be the minimum of, we want the distance between x and a to be less than 1 or within 1. So it's going to be 1 comma and an expression there in terms of epsilon, which will be our choice of delta. Together with this, we will determine the minimum. Step number 3, we are going to talk about the assumption step. So we assume, what do we assume? That this is true. 0 is less than the absolute value of x minus 2, and this is less than delta. We go to step number 4, the notice step, as I call it. What do we notice? Like I told you that this expression here always simplifies. So we notice that minus x cubed plus 3x squared minus 4 simplifies to, watch what I'm going to do inside there. I'm going to factorize it. Absolute value of minus 1, open brackets, minus 1 into that is x cubed. Minus 1 into positive 3x squared is minus 3x squared. Minus 1 into positive minus 4 is positive 4, like so. Now this simplifies to, if you like, yeah, simplifies to the absolute value of minus 1 times the absolute value of x cubed minus 3x squared plus 4, like so. Absolute value of 1 minus 1 is 1. We're multiplying that by absolute value of x cubed minus 3x squared plus 4, which simplifies to absolute value of x cubed minus 3x squared plus 4. Now there is a problem, but if you watched my previous video, I told you that whatever that expression there, whatever that expression here, this one here, whatever this expression, if I may rewrite this expression here so that we clearly see it. Yeah, just put my papers in order. If I may rewrite this expression here so that you clearly see it, I'm saying that expression x minus x cubed plus 3x squared minus 4, which we're saying is less than epsilon, this expression here, when you simplify it, it will always be a multiple of this part here, that part. That means that I can actually factorize this expression by using remainder theorem. I can actually factorize that. So I know the factor from this. I'm going to use long division here. So using long division, what do we get? We get this one here, x minus 2 dividing into x cubed minus 3x squared plus 4. And x into x cubed obviously is x squared. Multiplying this by that and that is x cubed minus 2x squared. We subtract like so. These two cancel, you can see these two cancel, but this one here, this becomes positive. Minus 3 plus 2 is minus 1, so I'm going to have minus x squared. What do I do next? I don't have the term containing x here. I have the term containing x cubed, x squared. I don't have the term containing x, and then I have a constant term. Basically, I'm saying a general cubic function should be in the form of ax cubed plus bx squared plus cx plus d. Now you notice this term here is not there, so I'm just going to leave it the way it is, and I'm just going to go straight. I'm not going to drop the 4 immediately. X into minus x squared is minus x, and then x minus x times x is minus x squared, minus x times minus 2 is actually positive 2x. Now I subtract. Obviously these two cancel, but this one now becomes minus, so now I have minus 2x, and then drop the 4, which is positive 4. Now we take the x into minus 2x, the answer is minus 2. Minus 2 times x is minus 2x. Minus 2 times minus 2 is positive 4. You can clearly see that this subtract, our final answer is what? Is 0, the difference. So let me call this asterisk. I'm going to say therefore asterisk becomes, what does it become? It becomes the absolute value of x minus 2 times x squared minus x minus 2, like so. Remember now, factorizing this, we just have to multiply that by that to get this kind of expression. Now, sorry about that. This is exactly equal to absolute value of x minus 2 times absolute value of x squared minus x minus 2, like so. If you notice here in the assumption stage, what did we say in the assumption stage? We assume that the absolute value of x minus 2 is actually less than delta. So therefore here I can say this is less than delta times the x squared minus x minus 2, like so, absolute value of that. Now we have to get rid of this, replace it by some number, some expression. Now if you remember here in this step, I said second step, choice of delta. Delta will be minimum of 1 and some expression. We want the distance between x and a to be within 1. So I'm going to say the distance, therefore, between x and a, which is absolute value of x and x minus 2, should be within 1, should be less than or equal to 1. So if I may use this side here, I'm saying we want x minus 2, absolute value of that to be less than or equal to 1. Using the definition of absolute value, this means x minus 2 less than or equal to 1, but greater than or equal to minus 1. That's the definition of absolute value right there. Let's simplify this. I'm going to add 2 there, 2 there, 2 there. Why am I doing that? I want to get x first, and then I will square. I want to produce this from there. So add 2 here, there, and there. You're going to get 1 here, less than or equal to x, less than or equal to 3. Now, how the triangle inequality works, like I've explained that I was going to show you today, how the triangle inequality works at this stage. So at this stage, if you look at the last part there, after simplifying this expression here, the last part there is x is less than or equal to 3. Now, you look at these two numbers. The inequality sign may change, may face the right or left, but you look at the two values, the bigger of the two. In other words, the one that has a bigger magnitude, not just necessarily the bigger, but the one that has a bigger magnitude. That's the one you take. And if you, in this case, the magnitude of 1 is 1, magnitude of 3 is 3. And if you take 3, which is bigger than 1, substitute there and there, this will give you 4. Because 3 squared is 9, minus 3 is 6, minus 2 is 4. And therefore, this can be replaced by 4, and we're going to say less than or equal to 4, and we carry on. But what I explained last time is the following. If you remember last time, I said I'm not a fan of triangle inequality, but I've shown you that this here will be replaced by 4. But let me show you how we get it using my traditional approach. Now I have x squared here, if you can see, x squared minus x. So last time I told you, we look at the coefficient of x is minus 1, divided by 2 is minus half. We're going to add it here, there, and there. So 1 plus minus half is 1 minus half, less than or equal to x plus minus half is just x minus half, less than or equal to 3 plus minus half is just 3 minus half. Simplifying this, we get half, less than or equal to x minus half, less than or equal to, if you check, this is going to be 5 over 2. So that's 6 over 2 minus 1 over 2, that's 5 over 2. Now I have to square the whole thing. So I am able to produce x squared minus x. Squaring this, I get a quarter, less than or equal to. Squaring this, I'm going to get x squared minus x plus a quarter, less than or equal to. Squaring this is 25 over 4. Now I have a minus 2 here. I don't have a quarter there, so I'm going to have to remove the quarter from there. So subtract a quarter from here, there, and there. This will be 0, less than or equal to x squared minus x, less than or equal to. Subtract a quarter from this one, it should give you 6. Right. Please convince yourself that 25 over 4 minus a quarter is 6. Now I have minus 2 here. I must subtract 2 from every term here. So subtracting 2 from 0, I get minus 2, less than or equal to. Subtracting 2 from this, I get x squared minus x minus 2. Subtracting 2 from 6, I get 4. Exactly like I told you. Taking magnitude, I'm now going to have 2 magnitude of minus 2 is 2, less than or equal to magnitude of x squared minus x minus 2, less than or equal to magnitude of 4 is 4. There you have it. This part here is what I was looking for, that part here. So we can replace it with a 4, and we say this is less than or equal to delta times 4, which is exactly equal to 4 delta. And like I've said in the previous videos, set 4 delta to be equal to epsilon, and solving for delta, you get delta equals epsilon over 4. And bringing this expression there, you're going to get 4 times epsilon over 4, and the 4's cancel, and your answer is epsilon, which should be the end of the proof. But remember what I told you here? We're looking for the minimum. We said the distance should be within 1 there. So we're going to look for the minimum of 1 and epsilon over 4, whichever is smaller depending on the value of what epsilon is. That will be the minimum of that would be the choice of our delta. This should complete the proof of this limit here. But remember, the triangle inequality is applied at this stage, and I'm going to repeat this. You look at which one of the two numbers has a greater magnitude. That's the number you take. If I had, for example, if I had -1 here and -3, I was going to take -3 because -3 has bigger magnitude compared to -1. So I would still take -3. In this case, -3 would be on the left, obviously. -1 would be on the right because -1 is bigger than -3. So I would still take -3. I'm saying if I had x is less than or equal to -1, greater than or equal to -3, I was going to take this one because it has bigger magnitude, and then substitute there and get the solution. Now in this case, obviously 3 has bigger magnitude compared to 1. So if you take the 3, substitute here and there, and simplify this, it will give you 4. But this is what I prefer because this is basically like working from first principles, or just that from first principles. All right, in this video I'm going to stop here. I have one more video on the precise definition of a limit. I'm going to be talking about the rational function and the radical function in one video. All right, if you're new to this channel, please subscribe. Let's share these videos with colleagues and friends. It will give us the strength, impetus, like I say, and momentum for us to be able to produce many more videos. All right, see you next time.